chapter is going to focus on proving triangles are congruent. And we're actually going to learn how to write some two-column proofs. And we're going to practice writing two-column proofs. Okay? And I know they may sound difficult, but there's a pattern to all of them. And I'll try to point that pattern out to you and try to make it as easy as possible. There aren't a lot of steps on most of them. They're all very, very similar. So if you do all of the homework problems, whether you do them after the fact and I'm doing them for you, or you do them ahead of time and you do them by yourself, it doesn't matter. If you do all of them, then there won't be anything I could possibly put on the test that you won't have already done. Okay, so a lot of being successful on this is just remembering what you're looking for and knowing the names of certain things. Okay? So I can identify congruent triangles using side, 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 and side, angle, side. That's what the SSS and SAS stand for. Okay? If we look at these two triangles, I'll give you time to copy these and I'll move it down so you can copy the postulate. So the side, side, side postulate, and again, whether you call it a postulate or a theorem doesn't matter to me because in the textbook I taught out of before this one, these are all theorems. And it just all depends on how they chose to go about presenting information leading up to it, and they chose to prove that this was true, and that makes it a theorem. This book chooses to allow this to stand as a statement that we accept to be fact. And so it says if three sides of one triangle are congruent to three sides of another triangle, then the two triangles are congruent. All right, so just to make sure you understand the symbolism here, a single mark here, a single mark on this segment and a single mark on this segment means those two segments are congruent. And so this is saying then that segment AB is congruent to segment what? Segment AB has a single mark on it. Okay, segment DE. Okay, remember to match them up. A is first in this one, so A will be first in, or sorry, D will be first in the second one. Okay? And so segment AC is going to be congruent to what? Segment DF. And then segment BC is going to be congruent to segment EF. Okay? So that's what those symbols mean. So if they have an equal number of little tick marks on them, that means they're equal in length, or the segments are congruent. And it's important that you realize that. Okay? Do you have any questions on what the symbolism means? All right. So what we're saying then is if all three sides of triangle ABC are congruent to all three sides of triangle DEF, then that means those two triangles have to be congruent. That's enough information to say they have to be congruent. So in other words, if I gave Ariana 3 sticks that make a triangle, by the way, you realize if I give her just any 3 sticks, she may or may not be able to make a triangle. Okay? It's possible I could give her 3 sticks that won't make a triangle, because 2 of the sides would be too short for the third side. Or you could look at it and say the third side might be too long for the other 2 sides. Okay? So just having 3 sides doesn't automatically make a triangle. But if I gave her 3 sticks and it did make a triangle, and I gave Sean the same 3 sticks, the same length 3 sticks, and he makes a triangle, I could take his triangle and her triangle, and I could flip them around and turn them over and rotate them, and I could make them match right on top of each other. Guaranteed it has to happen. And that's what this theorem is saying. No matter who's making the triangles, if you take these 3 facts, the lengths of these 3 sides, you can put them together any order you want, And that triangle can be rotated, flipped over, reversed, do whatever you want to it. You can make it match up on this one exactly. Okay? Even though they may not look the same, we can make them line up exactly the same. Okay? So if the sides are the same, it doesn't matter if they're facing a different direction or whatever, if the three sides are the same, then the two triangles have to be congruent. Okay? They have to be. Are these triangles congruent? Copy that down and we'll talk. So are these two triangles congruent? Silas, what do you think?
I think, yeah.
You think yeah? So what do we know about these two triangles that make you think they're congruent?
Both the same.
What do you mean are both the same? Both what? Both triangles? Go ahead, Octavia. Are they reflecting? I'm sure we could make them reflect, but there's nothing here indicating that they're reflecting. Amber, what do you see?
All sides are the same line.
Okay, so the three sides on the triangle on the left are what?
Are the same as the right.
As the three sides of the triangle on the right. All right? This length here is, whoops there. This length here is 4.5, and over here we have a 4.5. This length is 7.5, and over here we have a 7.5. This length is 7.6, over here we have a 7.6. So we have the three sides of this triangle on the left equal to the three sides of the triangle on the right. That means those two triangles have to be equal. Okay? So they have to be congruent. So the answer would be yes. And if they asked why, explain why, you would say yes by side, side, side. That's all the statement you have to write. Okay? And SSS is accepted as an appropriate name for that postulate. Okay? Side, side, side. All right. Any confusion on that? Okay? Side angle side then. Take a minute and copy this down. This postulate says two sides in the included angle, one triangle, are congruent to two sides in the included angle of another triangle, and the two triangles are congruent. The included angle, this isn't technical terminology that you'll find in the book. It's the way I describe it to hopefully help you understand what you're looking for. The included angle is the angle that's pinched between the two sides you're looking at. So if I'm looking at this triangle on the left, triangle ABC, and I have this side and this side, then the angle pinched between the two would be this one. So that would be considered an included angle. Okay? And then in the other triangle, angle E would be the included angle. It's pinched between segment FE and segment DE. So those are included angles. And so by this postulate, I have this side congruent to this side. I have this side here congruent to this side here. And I know the angle included between those two is congruent to this angle over here included between those same two sides. And so that's enough information to know that those two triangles have to be congruent. That's the key. We're talking about what's enough to prove that they're congruent. Okay? I want to expand on that in just a minute. Finish copying this down. Yesterday we talked about if we knew the triangles are congruent, then we made how many statements about the triangles? If I knew two triangles are congruent yesterday, we wrote statements about them, right? How many statements do we make about the sides? 3. And how many statements do we make about the angles? 3. So altogether there are how many statements of congruence? 6. 3 sides and 3 angles. You'll notice in this first one, side, 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 it took how many facts here to prove these triangles are congruent? 3. The 3 sides, right? We didn't talk about angles at all, did we? But we knew the 3 sides were. And then in this one, again, we have 3 facts. We have 2 sides and an angle. And so what we're looking at here is just showing you that if you get the right 3 facts, you can prove the triangles are congruent. You don't need all 6 facts, you just need 3. And so if you get the right 3, then that's enough to show these triangles are congruent. And so in this case, if I know 2 of the sides are equal to 2 of the sides over here, and I know the angle between them, the included angle is equal, then the triangles have to be congruent then. If I look at this one, I've already given it away. This is not side angle side. Here I have a side equal to a side, and I have another side equal to another side, and I have this angle in between, but do I have the angle in between in the picture over here? No, my angle is over here. It's not the one that's between, is it? And so in this case, I don't have this angle that's between them. I don't know what that is. So I don't have enough information to show that these triangles are congruent. So not every problem they give you today is going to be true by side, 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 or side, angle, side. It's possible they'll try to trick you and give you the same 3 facts, but not in the right order. If they're not in the right order, then they're not the same 3 facts. Okay? This angle here that they gave me equal to this angle, this case, it's not between my 2 sides. Even though it is on this triangle over here, it's not in the triangle over there. So it's not enough information. So this is not side angle side. Okay? Any confusion on that? Okay. That's it for the notes. Let me look for a second. I'll tell you what your assignment is. Okay, listen please. Listen. Your assignment, I want you to do 1 through 33 odds. 17 problems. 33 is it's a proof that they've given you all the statements. You just have to supply the reasons. Okay? I know that we're going to have some issues on that, but I want you to try it. And tomorrow we'll begin class by talking about that one and a couple others that we didn't assign. Okay? Remember, eventually I'm going to expect that you can write a proof. If we don't start slowly with these that are half done, you'll never get to where you can write one by yourself. So you have to make an effort on 33, and then when we talk about it, it'll make more sense to you. Okay? Don't just look at it and say, oh, that's a proof, I can't do that. You can do it, and you may stumble a little bit, but you can get some of it done correctly, and the rest of it we'll talk about and correct it tomorrow. Okay? Jeffrey, do you have a question?
No, it's mind over matter.
Right. So 1 through 33 odds.